Okay, this is the review of, what is it, 8409 is the number in the upper right-hand corner up there. This is the review for our waves test. Hopefully you can hear me, Chase. Don't forget to comment on the positive side for this one. All right, as a transverse wave travels through a medium, the individual particles of the medium move. So if it's a transverse wave, I'm just going to change to red here. Transverse wave, that means the particles are vibrating up and down while it's traveling. So this is the vibration. The traveling direction is left or right. So in that case, they would be perpendicular to the direction of wave travel. So you have this, the direction of wave travel is there, but the vibration is up and down. That's what transverse waves are. Whoops, I haven't done this in a while. Undo. How do I undo? So off to a great start. All right, next question. What type of wave requires a material medium through which to travel? Anything that is a mechanical wave. So sound is the best example we have there. Radio, infrared, and electromagnetic are all EM waves. They are able to travel through a vacuum. We'll get to those soon. Diagram below represents a transverse wave traveling to the right. These are always confusing. What the question is what direction will the particle move in the next instant of time? So you're at A right here. My advice is look at the direction the wave is traveling. So it's coming from this direction. So you look behind you and you see what's the next thing that this particle is going to see. It's going to see this trough right here. So if I erase everything that's on here, whoops, I'll use my eraser. If I get rid of all that stuff. What this particle sees is this trough, so it's going to travel down into the trough. Then it will start to go back up as this travels through here. So it's going to go down, and then eventually it'll go back up. If point A was right here, point A was right there, as this wave travels through, it would go up following the crest, and then it would go back down once this point went through it. So again, the advice, always look to see where the wave is coming from, and then just look and see what's coming. And in this case, a trough is coming, so it would go down first. Diagram below represents a transverse wave. Distance between which 2 points identifies the amplitude. Well, we know that this is the amplitude. This is also the amplitude also. And because A to D is not one of the answers, but A to E is, that's the best one. A to C is one full wave, so A to C would be the wavelength. If the amplitude of a wave traveling in a rope is doubled the speed of the wave in the rope will, nothing happens. Remember, the speed of the wave is controlled by the medium. If there's no change in medium, there's no change in speed. So you can have an amplitude that goes up, you can have a frequency that changes, a wavelength that changes. None of those affect the speed. Only the medium does. So remains the same. Increasing the amplitude of a sound wave produces a sound width. So amplitude is akin to the size of the wave. And for sound, that has to do with the loudness or the volume. Pitch, remember, is frequency. Lower speed, that doesn't have anything to do with it. And wavelength would go with frequency. They're inversely related. Diagram below represents a transverse wave. The wavelength is equal to the distance between, well, A to E would be correct. B to F would be correct. C to G would be correct. So let's see which one of those. B to F, that looks like the right answer. C to E is a half of a wave. D to F is also half of a wave. And A to G is 1.5 waves. What is the wavelength of a periodic wave having a frequency? So that's F. And a speed, V. I think you just do V equals F lambda. You guys can do the math and get that. I'll do it for you. So 10 equals 5 lambda is 2. Next question. Last question. The product of a wave's frequency and its period is. This is tricky. The frequency is defined as the waves per time. The period is equal to the time per waves. So the product of those is 1. Okay. The other way to look at it is T is 1 over F. So 1 over F times F is equal to